All right, we talked about yesterday, we talked about the Pythagorean theorem for the last couple of days, okay? We talked about the Pythagorean theorem. What are our parts to the Pythagorean theorem? Talk to me, Luke.
A squared plus b squared equals c squared.
Okay, a squared plus b squared equals c squared. Now that's what you're remembering, but now is that a part of the Pythagorean theorem? Okay, so is it not, or is it?
Wait, it's no.
It is the Pythagorean theorem, so explain to me then, Christopher, what the Pythagorean theorem is. Okay, so let's go back. Hold on. If I've got hypotenuse of what?
Right triangle.
Okay, right triangle, so we're getting more specific. So I've got a right triangle. And you said hypotenuse. I heard that word come out.
That's the longest side of the triangle.
Okay, so then how would I differentiate the longest side to the other two sides?
It's straight across from the right angle.
Okay, do you agree, Lane?
Yes, ma'am.
Why?
Because the ones that form an angle are your legs.
Okay, so you're saying the ones that form the actual, well, which angle? There's three
The right
angles.
angle.
Okay, the ones that form the right angle are my legs. Okay, now let's bring back what Luke said. So now, if I've got a squared plus b squared equals c squared, how does that come into play with this triangle?
The two legs can be A or B. It doesn't matter with them.
Okay.
But the hypotenuse has to be C.
Okay, so now we have been finding, so let me turn this around. What have we been finding?
The hypotenuse.
The hypotenuse.
We've been finding the hypotenuse. Is it possible to have the hypotenuse and have a leg and find the other?
Yes.
Okay. Now, today we're going to take what we've done for the last 2 days and we're going to actually use what we've learned with the Pythagorean theorem. Okay? Now, you've got your sheets. I've got about 8 problems on here. I want you to go back to your talking stations and I want you to illustrate each one of these problems on the grid paper that you have in your tubs. You can utilize grid paper, you can utilize your calculator, you can utilize anything that you need. Your geometry template is also in your tub. When you get back to talking stations, I want you to assign an illustrator in your talking stations. Does everyone understand this?
Yes, ma'am.
The picture that you draw or illustrate does not have to be to scale. Okay? Any questions? Talking stations. I don't know. Now in my talking stations, leaders, do not forget, you are the one reading the instructions. You are to keep everyone encouraged, stay on task. Yes. Ready?
An oak tree is 12 feet tall and a bird is standing on the ground, 16 feet from the tree. If the bird flies directly to the top of the tree, how far will it fly?
My ladder. So here's my wall. Here's my wall. What is my ladder doing to my wall? Okay, so it's this way. So if I have a ladder that's leaning up against a wall, it looks like this. Here's my ladder, here's my wall. Okay, now is this leaning? This is lying. So what would give me the picture of leaning? Well, now hold on. Now let's take the right triangle thing out. Let's just figure out what the picture looks like. If this is my ladder and it's leaning,
It would be like
okay, so
the bottom of a 13-foot straight ladder.
okay, so this is leaning. Okay, all right. So now, what am I looking at? What measurements do we know about this?
The wall. No, wait. Yeah.
Okay, so what's 13 feet then? Okay, so this is 13 feet. Okay, go.
And then the wall is 5 feet away.
Okay, so the wall is 5 feet away from this. So does it say anything about?
The ladder's
The wall.
Okay.
So we have to try to figure out what the wall is measuring.
What's the difference in this problem and my other 2 problems? And give you all 3 of the measurements. Now I've got to figure out. teach you, we gotta pause for just a minute. I want your bodies in group. Go. Let's go from our tree. Oh, I shouldn't have erased it. Okay, so I've got my tree, and here's my tree, and here's my chubby bird. Now, I'm finding now on my bird problem, I've got, what do I have that I know that, what information do I have? I've got,
Two legs that make 90 degrees.
okay, so I've got my 2 legs. What do I not know in this problem? Okay, I do not know my hypotenuse. Any questions with that? All right, that's number 1. All right, now number 2, what do I not know in my ladder situation? Okay, so here's my ladder, and I do not know my A, but I do know B, and I do know the height of my ladder, correct? Okay. Or 3. What's changed in 3? Okay, let me recap. Okay, ready? Luke says their group hasn't got there. 3, in shop class you make a table. Okay, table. And I'm gonna do a aerial view of my table. I'm gonna be looking down on my table. Okay? Now, the sides of the table measure 36 by 18 inches. Okay? Then it says that if the diagonal of the table measures 43 inches, what's the diagonal of my table? Okay, so my hypotenuse only goes with the right triangle.
Yeah, but the triangle makes a
Cameron?
It's like you take from one corner and then.
Because what's a part of that table? What did we talk about yesterday?
2 right triangles make a
It's
rectangle.
like
Okay.
a rectangle or a square.
Yeah, it's like TV.
So, this is my hypotenuse, correct?
That's your diagonal, because hypotenuse only refers to right triangle.
Okay, hypotenuse only refers to a right triangle, which in turn is my diagonal. Well, how are these 3 problems different?
They're all different.
Bethany.
Because on one, you don't have the hypotenuse. On
Okay,
the-
this, number 1, I did not have the hypotenuse. Number 2,
You didn't have one of the legs.
didn't have one of the legs.
And C, you were given it all, so you can see how they all came together.
Okay, so I've been given a square, which I've not been given a triangle, sort of. I've been given all 3 of the measurements of, so if, let me say this. If this is 36,
That's 36.
and if this is 18,
18.
this is 18. Kaylin.
Oh, to answer for that one, you had to. They're all different operations. Because that one you had to add a squared plus b squared equals c squared. This one you had to subtract b squared from c squared, and then this one you've got to do something.
Now, but the question is, let me ask you this. Logan, do you see where she went? With this one you add, subtract, and then this one not sure. Morgan, does that make sense? Michaela, any questions? Okay, y'all are looking at me funny. Ready? But it says, they want to know if the table is square, quote unquote. In construction, it says the term square just means the table has right angles.
No, that gotta have all the same.
No. Now let me make sure you understand this. With this problem, it's not asking if it's a square. It's asking if it's square. In construction, when you're asking if it's square, that means we've got to test it out to see if there's right angles to this table.
Oh.
Not if it's a square in 3rd grade square. We're asking if it's square, not a square. Does that make sense? Good.
I think we got it.
Okay, so how was our table?
After good. Wait, we got 40, not 40. So wouldn't be. Yeah.
So is the table
it's
square?
not.
So does it have right angles or not?
Yes, but wait.
No. It has right angles. Yes, it does. It has right angles. They're just the lengths are both.
It's not a square, it's a rectangle, but they do have
Now hold on. What is the definition of square in construction?
This term just means that the table has right angles at the corners. So yes, it is a square, but not.
How does it, hold on, how is it a square if it's got a measurement of 43 or 36 and 18? Can a table with a measurement of 36 inches and 18 inches be classified as a square? So we know coming in, is this table a square? What is the measure, what is the figure of this table? Okay, but so that's not my debate. What is my debate on this question?
If it is square.
So what does that mean, square?
If it has
Right angle.
Okay, so if it's got right angles.
Plus 36 squared equals 42 squared.
And how would I test out something to know if it had right
And
angles?
then 36 squared equals.
measure it with a protractor.
And then 42 squared equals 18
See if your two sides equal that hypotenuse.
So what does that tell me? Just because, okay, so let me ask you this. So if I tested this out in 36 squared and 18 squared, did it give me 43 squared?
No, it gave you 40.
Okay, so what is that telling me? If I've got 40 on one side and I've got 43 on the other, you're telling me it's not a square?
It's not a square.
How?
Because it doesn't have
Because the
right angles.
hypotenuse.
So,
But the hypotenuse should be bigger.
But the hypotenuse should be 40 and it's 43.
No, it should be 43, but it's 40.
No, it's not.
Giving you the hypotenuse.
it's giving you the hypotenuse, which is 43. So is the hypotenuse longer than the two sides given? Okay, so that works, and then that works. But what does it mean? What does it mean if I've got 40 on one side and 43 on the other?
Means that one side's bigger than the other. Or the hypotenuse is longer.
If I have, you're saying 40 and 43. So here's my table. Okay, here's my table. And I've got 36 and 18. And here's 43. Correct? If this does not, if these two together squared and added does not equal this squared, what is this telling me?
It's not
That's not
actually
right.
square.
That's not a right triangle. Because if it was a right triangle, then those two squared and added together would give you the hypotenuse. And it doesn't.
So what is it?
Another triangle.
It's just another triangle. So what does the Pythagorean theorem only work on?
Right triangle.
So it's